Okay, let's work out a conservation of momentum problem. So in this formula, or in this problem, we have an 1875 kilogram car going 23 meters per second, and it rear ends a 1025 kilogram compact car going 17 meters per second on ice. They'd say that so you don't have to worry about friction. In the same direction. The two cars stick together. How fast do they move immediately after the collision? Now, your book likes to call these car C and D, but I really prefer to just call them car A and car B. It's just easier. If you want to call them C and D, you can. If you want to call them X and Z, you can. It doesn't really matter. So let's write everything we know. We know that this is the mass of car A. So I'm going to write the mass of A is 1875 kilograms. And this is the initial velocity of A. Then we have 1025 kilograms, which is the mass of B. And then we have the velocity of B, and that's the initial velocity of B. And then it says they stick together, and we want the final velocity. And that final velocity is going to be for both cars. So that's what we want right here, our final velocity. Okay, so the first thing you want to do when you solve these problems is you're going to use the conservation momentum. So we know the initial momentum of the first car plus the initial momentum of the second car is equal to the final momentum of the first car plus the final momentum of the second car. And I wrote an I here instead of an F. Okay, so now we can go ahead and we can say that our mass of A times the velocity, the initial velocity of A, because that's our formula for momentum, plus the mass of B plus the initial velocity of B is equal to the mass of A times the final velocity. And I'm not going to put an A or B here because it's a sticky collision, so they both have the same final velocity, equals the mass of B times the final velocity. Now, if you want to, you can do this for the final side. I know some of you like to do this for the elevator problems and some of you did not. So it's up to you. You don't have to. But these two, this equals this, these are the same thing. So you can do that if you want. Now, I'm going to go ahead and I'm going to put my numbers in. I'm going to have 1875 kilograms times 23 meters per second plus 1025 kilograms times 17 meters per second. And I'm going to do it like this, but you don't have to. Plus 1875 kilograms plus 1025 kilograms. Now I'm going to take these two and multiply them together. And I'm going to get 43,125. And remember, the units for momentum are kilograms times meters per second. So I'm going to leave those, but we'll get rid of them soon, I promise. Then we have 1025 times 17, which is 17,425. And again, still the kilograms. times meters per second. And then we have our final velocity, and this total mass is 2,900 kilograms. Okay, these two have the same units, so I can add them together. That's why I kept the units, so I can know whether I can add things together or not. So they have the same units, so I can add them together. So that means I'm going to get 60,550 kilograms times meters per second. And then I'm going to get my final velocity is equal to 2,900. I haven't really done anything with this side in this step. Now I'm going to divide both sides by 2,900 kilograms so I can get that VF by himself. Now when I do this, our kilograms are going to cross out and we'll be left with meters per second, which is good because that's the units we want for a velocity. And when I divide these two, I get 20.88 meters per second. So that's the final velocity. And if you notice, it's a little bit in between the velocities of the two cars. So the initial velocity of the first car was 23. That's a little bit more than this. And the initial velocity of the second car is 17, which is less than this. So our answer makes sense because it's in between the speeds of the two cars.